So now we come to the multiplication of vector, which is cross product, where the product of the two vectors is another vector quantity. So we put it like this. We write it A cross B. We put a distinct sign of multiplication, that is cos, which is AB sine theta. And then you see, since this is a vector, we have to represent it by an arbitrary unit vector, which is U cap. So this is what we write for a cross product when we have that the multiplication of two vectors, which is another vector. Now first let us deal with the direction, then we will be dealing with the magnitude. How come AB sine theta? Regarding direction, what we should understand is that this vector A and this vector B, when I am multiplying these two, say I am multiplying A and B, not B and A, but A and B, there I move my fingers from here to there, and this is the angle between the two vectors, and the direction is perpendicular to the plane of A and B. So A and B is given by what we call a right hand thumb rule. That is, we rotate our fingers in the direction of the thumb of the right hand is the direction of A cross B. So similarly, if you are doing B cross A, then you start multiplying from here, B cross A, and you reverse your fingers. And in that case, you can see that B cross A will just go downward to A cross B. So B cross A and A cross B are just oppositely directed. So as in vector, we can put it by a minus sign. So you have A cross B, which is equal to minus of A B cross A. So that is the angle between the two vectors you can see here is distinctly 180 degree, or what we call it a pi radian. So this is all about direction that we have. I will repeat that if you multiply A and B, your swing of right hand fingers should be from A directed towards B, and your right hand thumb will point upward. So this is the plane of A and B. Now, if I can draw it in a planar manner, then I can show you one more thing to understand that A and B and their cross product will lie in a plane which are mutually perpendicular. So this is the direction of A cross B, and this is your A and this is your B. So the plane of A and B and the plane of A cross B, as you can see from here, are mutually perpendicular. So now we come on to the next part from direction, that how we get the magnitude. So let us now deal with the magnitude. Now for magnitude, say for example, we have two vectors, vector A and vector B, like this. And previously when we did dot product, we understood that dot product basically was nothing but finding the component of one vector on another. And here what you need to learn is that the cross product is all about finding out the area that is formed by joining these two lines and making it a parallelogram. So the area under this parallelogram that we have drawn just now is nothing but the cross product of A and B. So if I draw this right now, what we can find here is that if I make this as PQRS, if I make this as PQRS, then you can see, and I can join this, then I hope you understand that the PQRS, this PQRS is equal to twice of the triangle PS and A. I mean PQ and A. So I hope all of you got it, that the area of this PQRS is nothing but twice of the area of this triangle, which we have drawn as P, Q, and S. So once we have that, now you can see the area of the triangle is nothing but half into base into altitude. Now the base is nothing but A, so we put it as A, but the altitude, as you can see, is this one. So if this is 90, this is B, and this is theta, then surely this is nothing but B sine theta. So that leads us to the expression of of AB sine theta. So now these two and these two are struck off. So what remains is AB sine theta, which is nothing but the cross product. So this is how the sign comes into play when we write that A cross B is AB sine theta. Well, now one more thing that we need to discuss here about cross product. The cross product will now give us one more point which is very important. You see, we have an area like this, and as you all know by now that the direction of this vector A and B is directed along this line. So now if I consider this as an area, so that is what this becomes an area vector. So this area vector is always directed perpendicular to the plane. So that is why when we have learned in vectors about the direction of area, we say that the area is perpendicular to the plane. Why? Because area complies of cross product, and cross product is nothing but a direction perpendicular to the plane of the other two vectors that we are multiplying. So as you are multiplying the sides of this parallelogram or the triangle that we have formed by breaking up the parallelogram, so this gives us the direction of the area vector. So that is how we come to the value of the area vector. And finally, you should know that we have along x-axis a unit vector of I, you have along y-axis the unit vector of j, and you have along z-axis the unit vector of k. So they are multiplied accordingly and calculated. Okay, so that's all for right now for the cross product. Thank you, students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.